Hi everyone. In this video we will learn about voltaic cells. How electricity is produced in electrochemical cells. Not only voltaic cells, it could be the electrolytic cells or the voltaic cells. But basically we will talk about the electrochemical cells. It produces energy or electric current. As you know, by definition, energy is the ability to do work. So let me grab a pen. And then let's define energy. Energy is the ability to work. So in this chapter, we'll talk about law of conservation of energy. Energy can either be created or destroyed. We'll talk about how the chemical energy is converted into electrical energy. So that is where the electrochemical cells comes in. Electrochemical cell. The job of the electrochemical cell is to convert the chemical energy, okay, into electrical energy. So how do we do that? What is the equipment that we use? We can use two different types of cells. One is called voltaic cell, okay, voltaic cell, or galvanic cell, same thing, okay, or the other one is electrolytic cell. Electrolytic cell. Well, as far as the voltaic cell is concerned, it is going to convert the chemical energy into electrical energy. So it is going to do this job by a spontaneous reaction. Okay, it is going to do this job by a spontaneous reaction. This is going to convert electrical energy, electrical into chemical, okay, by non-spontaneous reaction. Like you would have to provide the energy for that. You would have to provide the battery to make this reaction work. It will not work on its own. You have to provide the source of energy to make it work. Whereas voltaic cell or galvanic cell will work on its own, and it will convert the chemical energy into electrical energy. In the cell, there is another term that we will learn that are called electrode. Electrode is a conductor of electricity. So the next thing we want to learn, hold on one second, what is this doing? Electrode. Okay, there are two types of electrodes. We have anode and we have cathode. Okay, the reduction happens at cathode. So reduction happens at cathode and oxidation happens at anode. Right? So oxidation happens at anode, reductions happens at cathode. But the difference is that in the voltaic cell, okay, in the voltaic cell, the cathode is the positive electrode. Okay, cathode is the positive electrode and anode is the negative electrode. Whereas in the electrolytic cell, okay, the cathode is the negative electrode. Okay, cathode is the negative electrode and anode is a positive electrode for electrolytic cell. There are two types of cells, I'm telling you. So for electrolytic cells, the second one, the cathode is the negative electrode, okay, and the anode is the positive electrode. Whereas for the voltaic cell, cathode is the positive, they're opposite to each other. So, but what exactly it is? So it is like a metallic plate, okay? One is going to be positive, one is going to be negative, and so we call it cathode or anode. All right, so but I'll tell you where it comes in, what role does it play, how it works, and all that. So to understand that, let's talk about a chemical reaction. Let's take zinc and react it with copper sulfate, and we know that it is going to do zinc sulfate plus copper. So I hope you understand what I'm going to do here. Zinc is neutral and zinc becomes positive 2. So it has gone through the oxidation, okay? The, the charge increases and it went through oxidation. The copper, who was positive 2 here, it went to neutral. So copper has gained the electrons that it had lost. So copper went through reduction. Uh, the oxidation number decreased, and it went through reduction. All right. So these are the two half reactions. So let's write those half reactions. So is going to zinc plus 2 and plus 2 electrons, and copper, who was here, all right, is going to take those 2 electrons and become copper, neutral. So I have these two reactions. I have, so this is oxidized, all right, and this is reduced. So you need to understand who is the oxidizing agent, who is the reducing agent. If I cancel my balanced electrons, the overall reaction is going to be zinc, which is neutral, is going to react with copper to give me zinc plus 2 plus copper, which is neutral. Okay, so because copper is more electronegative, all right? So copper is going to take those 2 electrons easily from zinc. So we need to talk about we need to see this reaction in terms of activity series, all right? That which metal is going to do this, which metal is not going to do this. And we can also look at it in the light of electronegativity. So since copper is more electronegative, so copper will say, okay, give me these 2 electrons, and I will become neutral. And since zinc is more active, in terms of activity series, zinc is more active, so it will force copper to oxidize it. Okay, so however you want to take a look at it, this is how it works. So this, if we do this kind of reaction, if electrons are moving from zinc to copper, why not use that electron for some purpose? Okay, so we will say, okay, if I take this solution in the beaker here, all right, so I'm going to take 2 beakers because the voltaic cell happens in 2 different beakers. The electrolytic cell is all happens in one. So I have 2 electrodes here. All right, I have 2 electrodes here. These are the 2 plates. All right, and one of them is cathode, one of them is anode. So oxidation is happening here. So I told you that if you pay attention here, that cathode is the positive electrode in the voltaic cell. So oxidation is going to happen here. So this is going to be the anode, and the other one is going to be the cathode. So what is this doing? All right. So this is the anode. This is the cathode. So if this is the cathode, the reduction will happen here. Okay, if this is the anode, the oxidation will happen here. And who is being oxidized? Zinc is being oxidized. So this is the zinc plate. All right. And in here, I have a solution. All right, I have a solution of copper sulfate. Okay, that will turn into zinc sulfate. So I have a solution of zinc sulfate here and copper sulfate here. So what is happening is that this is going to lose, and this is going to lose electrons, this is going to gain electrons. Okay, so copper right now is copper positive 2. Zinc is neutral here. So if I want to use this for some purpose, I'll say, okay, let me connect them with a wire. Okay, so the 2 electrons that zinc is going to lose, those 2 electrons will flow this way. Okay, so electrons are coming from the zinc. Okay, zinc is going to give up those electrons, these electrons are going to follow this path and go down to this solution. Okay, and this is copper. So what's going to happen eventually is that the copper 2, which is sitting here as a copper sulfate, will take those 2 electrons and accumulate on this plate. So eventually this plate is going to get heavier. Reduction is happening here. It is taking the electrons. And I'm going to lose the zinc here. So zinc is losing. When zinc loses the 2 electrons, zinc plus 2 comes out. And copper takes those 2 electrons. The copper, all the copper positive 2 that is sitting here, is going to take those 2 electrons and accumulate on this cathode plate. Okay, so if this reaction happens for a long period of time, you will see that zinc is losing those electrons consistently, copper is gaining those electrons. So what you will see eventually, that in this beaker I will have too much of zinc positive 2, and in this beaker I have too much of sulfate negative 2, because all the copper is going to be reduced and get accumulated on this plate. Okay, so eventually it's too much sulfate left in here, and eventually it's too much zinc positive 2 is left in here, and that is not a balance. Okay, so it will not so this current will not flow forever. Okay, for me to make this current flow consistently without any interruption, I need to make sure I keep the solution, I keep the amount same. The electrolytes should stay same. So what I'm going to do is to keep the flow of these ions consistent, I'm going to connect is with a salt bridge. Okay, so what is this salt bridge going to do? Okay, the salt bridge is made of, let's say, sodium sulfate. So what's going to happen is, eventually when I have too much of the sulfate in here, the sodium ions, okay, the sodium plus ions are going to travel this way and react with that sulfate to keep the balance. And the sulfate negative 2 ions will travel this way to react with the zinc plus 2. So that zinc plus 2 concentration does not increase too much. It gets balanced. So zinc keeps coming out. Okay, so when zinc keeps coming out, so that the solution doesn't become saturated. So because any zinc that is being produced will react with the sulfate and become a salt here. And any copper that is accumulating on the tray here, on the electrode, is leaving behind sulfate. And so that makes sure that I don't have too much concentration of sulfate. The sodium comes in here and become the salt of sodium sulfate. So since I keep the balance, my current will continue consistently flow. Okay, I can even record, I can put a battery here of, to see how much if this current is flowing. And I will discuss that in a second, that how we can use the battery to make that work, and how can I record that current. But anyway, this is how the chemistry of the voltaic cell works. That you have 2 electrodes, you have an anode here and a cathode here. Reduction happens at the cathode. You can remember it by red cat. Okay, red cat. That reduction happens at cathode. All right. So anox is another way of memorizing it. That anode oxidation happens at anode. So I have a plate of metal. Okay, metal is it's a conductor. Electrode is a conductor. So I have 2 electrodes. One is losing electron, one is gaining electron. When this loses electrons, those electrons are following this path, okay, and they go down into this solution. Copper here accept those 2 electrons and get accumulated on this, cathode electrode. So this is basically the whole chemistry is. You need to understand the purpose of the salt bridge. The salt bridge, this is called salt bridge. The salt bridge keeps the balance of the electrolytes, okay, so that none of them gets supersaturated of any one type of ions. So this is how this whole thing works. So let me see now what your note says. So in the voltaic cells, electrons are spontaneously transferred. So the example I gave you was zinc and copper sulfate. So electrons are spontaneously transferred from the zinc to the copper, the two electrons that were going. Electrons only flow one way in redox reaction. So it's not that these electrons are coming this way and these are coming that way. It doesn't happen here. So electrons are only going in one direction, okay? From higher to lower potential energy. So you can keep that in mind. Then I explained to you how this whole thing works. So voltaic cells, the half reaction occurs. So we talked about the half reaction, that zinc becomes oxidized and gives out two electrons, and then copper, which was in positive 2, it will accept those two electrons to become reduced. So these are the two half reactions. The half cells generally contain a metal electrode in a solution of the same metal ions. So this has a solution of zinc sulfate. So same metal ions. So this is the electrode, all right. This is the anode, the positive electrode, and this is the other electrode. So I have two different solutions. So this is the anode, this is the cathode. An electrode potential is created. So electric current is being created right here. All right, so we continue working on this. So you see here, this is telling you, this is using the example of nitrate. I use the example of sulfate. So that doesn't really matter. So oxidation occurs at the anode. I told you that zinc is going to lose the electrons to become zinc positive 2. So this is the zinc plate. Okay, this is the copper plate. So zinc is going to lose the electrons to become zinc positive 2, and the salt bridge is going to provide that nitrate. So that zinc positive 2 and NO3 react to make zinc nitrate. Okay, and the two electrons go out this way. So I can start and stop the current. So oxidation occurs at the anode, reduction occurs at the cathode, which is right here. We use an ionic salt bridge to keep the charges balanced in each half reaction. So I hope you understand the purpose of the salt bridge. It keeps the electrolyte concentration balance. Okay, so again, you need to understand there is a difference between the voltaic cell and the electrolytic cell. In the voltaic cell, it happens in two different sections. Okay, both electrodes are not sitting in the same beaker. And then I have the current here that I can, the battery here that I can record the electric current. Again, this is another way of explaining it. Same story over. So electrons flow through a wire. So electrons are flowing through a wire to the cathode. The cations formed at the anode dissolve into the solution. Okay, and the cations in the cathode are reduced to a neutral metal. So copper is being collected right here to a neutral metal and deposited on the cathode. So electric current is being produced. Now we can measure that electric current, like how much electric current is produced. And to calculate that electric current, we use a battery, but we are calculating it in reference to the electromotive produced in reference to hydrogen ion, standard hydrogen electrode. So all the electric current that you record is comparable to the standard hydrogen electrode. Okay, so to do the 1/2 reaction, if you look into your data booklet, it will give you these numbers. Okay, the table of electromagnetic potential is given in your data booklet, and that data booklet tells you that the half reaction of zinc that gives you zinc plus 2 electrons. Okay, the relative strength of that half reaction is it produces 0.76 volt. Okay, again, as I'm telling you, it is in comparison to hydrogen. And then the other half reaction, which is copper positive 2, accepting those two electrons, which is the reduction process. Your data booklet tells you that it produces 0.34 volts. So to calculate that how much total current will produce through this reaction, I'm going to add them together. So it will produce 1.1 volt of battery. So I can run a battery that is 1.1 volts from this chemical reaction. So these notes will tell you the same thing. I have this math right here, that the oxidation gives you this much current, the reduction takes this much current, and you add them together. It's different ways of doing it. You can reduction minus oxidation, but since it is still negative, because it is reduction minus oxidation. So it's 0.34 minus 0.76. So you add them together at the end. So you have to memorize, excuse me, you have to memorize these formula, but I don't think there are many questions on that. But these numbers should be given to you. You just need to know what is the formula. Okay, so this is all about electrolytic cell. Let's talk about, I mean, that was all about voltaic cell. Let's talk about electrolytic cell. The electrolytic cell is the one in which electric current is not produced spontaneously. You have to provide the battery. You have to force the electrons to be out of one electrode and go to the other electrode. In electrolytic cell, the anode is positive. Okay, earlier on we had that anode was negative, and so it is opposite to that of voltaic cell. So oxidation happens at anode, and cathode is reduction. That doesn't change. Okay, this is the same for both. So you see that both electrodes are in the same beaker. So you are going to produce the power here to force the electrons out of one electrode to the other. Okay, and that's all you need to know. It is just the aluminum reactor that tells you. So this is again the diagram of the electrolytic cell, that electrons are forced to go from one plate to the other. Okay, we can take any kind of salt here. Like if I take sodium chloride, so it's electrolyte, by electrolysis I can separate them. So for that electrolysis, I have to provide the energy to break this bond. So when I break this bond, the electrons go from sodium to chlorine, right? So that's what I'm saying, that you can take a molten salt that to dissociate into its ions. So I can take the potassium, which is liquid. It takes the electron to become potassium, and bromine takes the electron to become Br2. So they will, like if I have sodium chloride, basically, so I will make this sodium oxidized and the chlorine also reduced. So they will take their electrons back. So I will force them to go to give up their electrons. So this will become solid and this becomes gas. All right. So let's say this is a liquid. I have a molten salt. So I take a molten salt and I dissociate into its elements. And again, it's producing some kind. It's using the current. It's a different kind of salts are using different kind of currents, and that's about it. That's it. That's all you need to know. How the electrolytic cells work. And how do you compare the voltaic cell with the electrolytic cell? That's all the electrochemical cells are about. So we will do more practice in the class. I just wanted you to understand how the two cells work. So I'll see you in class tomorrow. All right, everybody. Thank you for listening. Appreciate it.